Okay, so this is the same problem as was before, but now we need to average power. All right, so now what we do is you basically look back at what we have done, and we know that first of all, well, let's draw a picture first. All right, this will be V. This will go into a resistor first. All right, an inductor L, and then a capacitor C, and then we'll plug it back in. So now, when you are dissipating power, the only place you dissipate power is right there, right? So to get the average power, all right, what we need to do is just figure out basically what the power dissipation across this thing is. So power is equal to going to be V times I across the resistor, the voltage drop across the resistor. Well, what's that? That's just basically I squared times R. Okay, and I we determined previously is dq dt, and we previously computed that thing out above, right? This was something funny looking like so. So let's go ahead and copy that down, right? So in that case, I is going to be equal to minus omega v over L divided by, now I'm going to write out that square root part, square root of omega 0 squared minus omega squared, entire thing squared, plus omega squared R over L squared, okay? And then one more thing, so then that is going to have a sine omega t plus delta, okay? And I want the average power, all right? So what I want is, let's plug this in. So that's the power. The power, instantaneous power, is just going to be basically I squared times R, which if you plug this entire thing, it's going to be omega squared V over L, entire thing squared. The square kills that square root, so that's going to be omega squared minus omega squared, omega entire thing squared, plus omega squared R over L, entire thing squared again. And now this is a sine squared omega t plus delta, and this multiplied times R. So let's bring the R right there. There's my R. Okay, so that's my power, but I don't care about my power, right? I want my average power, right? So my average power is just basically integral 1 over t, okay, 0 to t, so this is over one wave period of basically the power dt, where t is basically 2 pi over omega. Okay, all right, so let's go ahead and do this thing. So there's going to be a bunch of stuff. I'm going to call this stuff rather than writing all that stuff down. Okay, and then we're going to do the stuff in a second. This is all constant, so I don't really care about it so much. I have a 1 over t integral 0 to t of sine squared omega t plus delta, okay, dt. All right, so at this point, basically, if you've seen these problems enough, you already know that this thing here will just give you a half, right? But if you want to do it correctly, what you can do is you can write as following. So this thing right here, all right, sine squared is basically 1/2, and I believe this is a plus 1/2 cosine 2 times omega t plus delta. Right, this is one of these half angle formulas and stuff like that. All right, so let's go ahead and do that one. So it's going to be equal to some stuff times 1 over t integral of 1/2, okay, dt, plus integral of 1/2 cosine 2 omega t plus delta dt. All right, 0 to t, 0 to t. Okay, so this term right here will turn out to be 0, right? I won't prove it. You can go ahead and do the computation yourself, right? But basically, the thing is that you integrate cosine over 2 periods, essentially, and so this thing will turn out to be 0, okay? This thing, on the other hand, basically, you're integrating from 0 to capital T, so this gives me 1/2 times capital T, but I'm divided by capital T here, so it's just 1/2. So this is just going to be 1/2 times the stuff, so that's just going to be 1/2, And then let's write this stuff down. Omega squared V over L, entire thing squared, times R, divided by omega 0 squared minus omega squared, entire thing squared, plus omega squared R over L squared, right? And that is the answer then. Okay.